So hello everyone, this is a part 2 of the demonstration of a ROOTSCOPE. I will start from the user interface here. So the user interface is quite simple. So you have one message box at the top and a canvas at the bottom here. So all the default root behavior like right click is still available. For example, you right click here, touch 1D histogram, and you can see the draw panel coming up here. So that's what you're supposed to be very familiar with, alright? So also you have the same, you can access the same key combination from the default. Alright, so let's go to the displays here. In many cases, we will switch the histogram, like from a 2D histogram or 1D histogram or multiple 1D histograms. So here you have to display. You want to display. You hit D for displays. So you will pop up a window or a dialog for you to enter here. So you just type in a number 1, 2, 3, 4 here. So for example, I want to see the first one here. I just type 1 and I type enter or click the button OK here. So I click enter. So you go to this here. So I can do other thing like type 1 and space and 2. Then I will have 2 histograms showing up together side by side. Also, I can type 1, 1, 1, 3, 1, then there's 3, 1 here. Okay, and if you type in something like 1 and 99, okay, 99 is definitely out of the range, so it will definitely not display. And you type 2, so you could give it 1 and 2 here. Alright, so very simple. And currently, I set up to 10 histogram display together at the same time. And another case you would like to switch back and forth with 2D and 1D, you can use a Q and Control Q command. When you type Control Q, you go to the 2D, and the Q again, you back to the original setup or original display for 1D histogram. But just for a short note, sometimes the histogram size with 2D histogram size would be very, very large. For example, the spinning would be 6,000 by 6,000. So the rendering would be very, very slow. So if the rendering not finished and you type another key, it tends to crash. So I just recommend you, if not necessary, don't use a 2D histogram. At least, I mean, avoid the crash. But especially when the size is very large. For my case, is yes. Okay, okay, because at 6,000 by 6,000, you probably need to wait a lot of time before it's finished the updating. Okay. So then we go to the marker, and actually marker is pretty important in a ROOTSCOPE here because it set up the range that action will apply to. There are several ways to set markers, and their response sometimes will be different according to the dimension. The dimension means the x minimum and x maximum will be the same. Okay, so let's go back here. Okay, here this is -3 and to the 3 in y-axis, and -3 to 3 in x-axis. So their projection will have both dimension here. So just as what we see here. Okay, so in this case, when you click on it, you will see a line here from both paths here. If they are not in the same dimension, you will just see the line in the active path. So just for a demonstration, I will make this guy not the same dimension with this guy. I will talk about how to do this. So I can use Alt R, that's a change the range, but keep the same beam width. That's pretty cool. Let's say I expand it to phi to minus phi here. So what happens? So you can see. So now it would be minus phi to phi, but here is just minus 3 to 3. So when I click that, you see there's no line go to the second pad. Okay, so that would be a different set of line. So that make it back to minus 3 to 3. I hit enter. Okay, now it's going back here. Okay, so this is the first command, probably very useful. And you can use mouse right click or use M to mark, to hover the direction, hover the position you want, and type M. So sometimes you want to input more specific location, you can use Auto and M. Here it pop up a dialog for you. So for example, I want to type 1.2 and I don't know where's 1.2, so I type here. So you set it here. The very first click is always black, and the previous one or second one will be turned into the yellow. So you see, okay. There are another set for the 1D histogram. That's quite handy for some case like you have add and subtract gauge the projection, or you have double Gaussian fit and you need another position as your reference. So in this case, you press Control and mouse right click. You see, there will be a different set of line. This is a green dashed line, and this solid yellow and black line. They are different. Okay. Alright. So I think how to clean the line, just clean N. Just none of them would display. You just kill them. Okay, so this line just show you the market position, and this is quite important for picking up. So for the 2D here, actually it's almost a similar thing. So the Control Q back to the 2D, and but because you know, if you use the if you just use a click to make a marker line, you sometimes would have the effect of zooming, because you want to zoom in here. You use a click and drag it, but somehow I don't like it. It would have some duplicate effect. So okay, it's complicated. So I use a Control and click to set a line here. Okay, so this is a line marker line here. So you can see there's a rectangular shape here. This will be the region the action will apply to here. So again, to clean the line, type N here. Okay, very good. Actually, very easy, right? So that's a very useful thing to browse the histogram. Either 1D or 2D is expand or undo expansion. So let's try the 1D first. Yeah, use Q back to this display here. So let's try just 2. Okay, so you have several options to expand. So first you can click. For example, I want to zoom in this range only. So I type small e here. Then I remain. Okay, and I remote is code out, O-U-T out, so it's out. So for example, if I go here and I want to zoom in from the range -1 to 1. Now I cannot click that, right? Because in my display I don't have the -1 in my range, but I can do the big E, Shift and E here. You can type -1 to 1 and hit enter. Now you get it. Okay, this is an input method to do that. Okay, so the same thing for the 2D. You can click and type expand E, and you zoom in and type O out. You zoom out here. So this would be more easy for you to explore the area you have interest in. So now we will go to the number 8, the arrow key to navigate the histogram. So that's will be much interesting here. So for example, this is spectrum number 1 here. We click that, you will see spectrum number 1. And we want to change it by spectrum number 2. Okay, so let me just remove it first. And I type arrow key up. You see, it go to the spectrum number 2 and keep the same range we expand. So because the marker we already set in the spectrum number 1, so supposedly if I type E again, you will go back to the -3 and 3 because this will be set in the spectrum number 1 and we don't click anything on spectrum number 2 yet. Okay, so doing the same thing, is arrow key up to increase the number of spectrum. We will go to number 3, okay, 4, okay, going down, you type arrow key down, going here down. Sometimes you will see a blink. I think this is a issue from the root itself because when you click too quick probably. So sometimes I would, between the arrow key, I would type E or N that make sure it has time to respond. For example, you see if I type E every time when I click the arrow key, it then blank here. Okay, so the arrow key up and down will change the spectrum, and arrow key left and right will change the range of display of a histogram. So just make fun. So let's go to number 2 here, and we set the range of a Y first. That will be make visible more easy. Okay, so we'll zoom in here. Okay, so now we go to the right hand side. If I click a right arrow key, you see the change, right? I think that's sometimes useful when you have some peak and you want to zoom in and change the range. Fortunately, there's some blank. I don't know how to solve it right now. Okay, so that's it. So very easy to browse. Again, if you want to zoom out, just type O out, zoom out again. Okay, so the next thing I already show you the limits in the display in Y or Z. For 1D histogram, currently I just set the Y maximum. So you type here, this is the current value 322, but I want to set 500. You can go to the 500 here. Okay. So if I want to back to the orange default or initial setup, I type O, back here. For the 2D histogram will be a little bit tricky, and maybe I could change that a little bit later because I think it's a little bit difficult. Maybe I can just one key to do that. So you type Z to set the maximum cut. So there will be no count over the 45. Or now you want to set the upper limit will be 20. Sometimes hard to see, so I make it colorful here. So you see, I type F1 to make color, and you can see this will switch. Okay, so you type big Z, it was set a minimum. Let's say -1. Let's see what happened. Yeah, okay, very funny. Okay, and then we just want to back original setup, type O again. Everything will back here. Okay, so this is for the setting the range. Sometimes it's useful. For example, you think this is one count step, it's just a background, and you want to eliminate background or noise before you do the projection. So I think that's quite useful. So you type big Z and type 2, and this is noise just gone, and you do the projection, and this is more clear, and you should see a real coincidence or real data here. Okay. Alright, so back to O here. Now let's go to nesting. Nesting is pretty cool here. Type Q back to the display here. Okay, so now we go to true histogram here. That will be shown more easily. So now, because it's just a compression for one histogram, 1D histogram, which is a compress axis, right? So you type X for compression. Notice you see the binning is reduced. Okay. So you see a number here, 7, 8, 9 is the equal to rebin equal to 9, rebin 8 something, and also you shift X was back to its way here. Okay, very cool. Do this again. X to increase the compression or rebin degree, and shift X reduce it. So sometimes you see the binning is too small, too fine for your histogram. You can use this trick. Okay, and you always come back to its original setup. That's quite useful. So for the 2D histograms, there are 2 axes, so there will be 2 means. So we use X for rebin or undo rebin x-axis, so Y or big Y for rebin or undo rebin or y-axis. So to make it more easy to see the change, so we use a color. So let's type F1 again. So we type X. It makes you see the binning is increased by 1 in x-axis. Okay, so that's back, and we can also change the Y. This is the Y binning, the X at the same time. Okay, so again, you can always back to its original setting here. Alright, very good. So now we're talking about the fitting. So we will have the background and Gaussian fit and the sum. So we were talking about the first situation is setting the background. So let's go back to the 1D histogram here. So we use the second one to do the demonstration. So for this background, there are 2 type of background so far. One is the linear, one is the constant. So constant means you just have the flat line, and linear means a linear line here. Okay, so use a B key for the background. Would be produce a constant background. It would take average of the count here and take that value as your background here. So you will see the background 6.45 here, and you can use collect the range first. Let's let the B, then you will get the background value here. For the linear background, you click the set up the range, then you type 1. So it will fit this part as your linear line. So that is extended all the way up to your screen here. Alright, so once you set a background, you can go on to do the Gaussian fit or sum. Alright, so for the Gaussian fit, just single Gaussian fit is very straightforward. Just click the range you want to fit, and you type a G here. You get a kind of awkward linear fit. So let's say the background is almost 0. Click here and click here. Got a Gaussian fit. So you give you the center is here. And it give you the area versus the compression, and it's this, and it's the width here and the chi-square fit. So the reason I use area divided by compression number is that the area is kind of height times base here. So when you compress or rebeam, you actually increase the base here, and your height also increase. So it would be doubled. Okay, that means that if this number times 4, actually you will measure time 4 times. However, it should be, I mean, the intensity or the area under a peak, if that means the intensity should not depends on your compression. That otherwise that would be a little bit hard to compare this peak under compression 1 to another peak under compression 2. So I use this quantity to identify the kind of a frequency or intensity of that peak here. Okay, alright, so that back here again a little bit. So I already demonstrate the Gaussian fit by pressing the key G here. So just in case I didn't show you, I can set here and then click the area I want to fit and type G here. Alright. So for double Gaussian fit, I need a nice spectrum. So I will change the setup here. So I will stop for a moment. Okay, I already opened root files that contain 2 spectrum here. If I remember correctly, there will be a peak around this region, I guess. Right. So suppose we want to fit this guy here. So because it is look like a peak with 2 Gaussian overlap each other, so we can fit by double Gaussian fit. So first I will set a background. Then I would like to fit this part. Then you can type Shift G, that's being a big G, to manually input all the parameters, but I don't want to do that. I use the Control click to click the where I think the peak is or the center is. Then I hit Shift G. It will help me to input the initial gas here. So I don't know the width, but I can try. For example, I try 10 and 10. Maybe not good, okay, but I can try again. Maybe I say 15. So I type 15 and 15 again. Alright, it looks better. So it's to me a peak, first peak here, second peak here, then the area and the width here. Very simple, right? So just recap a little bit. So first we set a background. So then we click for fitting range, and then right click to center for us to get an easier input. Then hit big G. Then you type in whatever you think possible. Let's say 1, and it's 20 Okay, this fit definitely very bad. Alright, okay, so let's go on next part here. Alright, finding peak, I think I can still use this histogram. This is pretty cool. So let's go back to the first one. I think it's easier. So here we have a lot of peak here. So sometimes we just have a quick overview where the peak is. Then you can type F for finding peaks. So you type F. You see here it will search the peak automatically and showing you up the label. So we can zoom in again and type F. So this just show you the very rough estimation where the peak is. If you need to know more precise, you probably need to use the Gaussian fit again. So you see here, very cool. So the thing is, you can change setup a little bit. So by default, I set the minimum sigma value is equal to 0.2 and the threshold is 0.1. That means 10%. So it would cut off 10% of this big peak. So everything below the 10% of this big peak would not be found. So you can probably lower it about 5%, and you can increase the decimal point of this, also text. So tab F, you see a little bit bigger. So if you don't like that, you type Control F and maybe type 40. So let's see what will happen. I never tried that before. So it become very large. Alright, so you can use the arrow key to right. Do that, you see, very quickly. And also, if you have two spectrum, you can do that all the same. You tap F, ooh, tap F, ooh, very large. I think too large. I think 16 would be easier. Okay, tap and again and again. So that would be very handy when you, especially if you want to compare where the peak is. So you see here. You see this is 2177, 2178, probably the same peak here. Okay, so and this here, this peak original nothing. Now you pop up here after the Doppler correction. Very cool, right? So another thing is that you can overlap to spectrum. So you can easily identify where is the change. For example, I already tell you here is very different, but how different it is? You can type C for cover or whatever to overlap this. So the highest peak would be scaled to the same label. All the man over 90% of the height in the canvas here. So sometimes it's not so visually easier to because the structure changed too much. But sometimes you can see they are different a lot. Okay, or here, yeah, overlap. Here you see this peak is going up a lot. So you see definitely the spectrum 1 and spectrum 2, this peak and this peak change quite a lot. Especially here you see become nothing. Again here. So remember when you overlap this and you type C again, you're back to normal mode. C again, you're back to the overlap mode. When you want to move back and forth, I recommend you back to the normal mode, then you move, then cover, and back again, and move, cover. If you in a normal mode, so in the overlap mode, you press the key like compress, you will only act the first spectrum, or do nothing. Okay. So for example, I press X, see, you go back to the first spectrum link, make it meaning more coarse. Yes. Okay. Back to the original one. So this is a C for cover, and also we can use sorry. Well, when we want to use the C key, we have to make sure we have two spectrum opened. But if we just have one spectrum, you can type Ctrl D. You can select the one you want to overlap here. Okay. Back to now. Remember, when it overlaps, the style still will be kept. So type F1. That would be change the filling style. Then you can type C. You can see it's overlap. Okay. And with the filling, also you type F2, change the width of line width. Type C, still there. Okay, so set it back. Alright, good. Now we go next one. Okay, projection. Alright, projection would be a little bit hard, but I think this spectrum is a little bit difficult. But I try to let me try it. Okay. Okay, projection. The concept projection is related to the gate, because you use the gate certain range, and you get a projection. And if this is apt to the projection, if you see a peak here, you will know this peak will corresponding to this region. So they have a coincidence relation. It's very useful for either the gamma ray spectroscopy or particle gamma coincidence, or whatever you want to know the coincidence relationship. So the small p key is for gating on the X, projects on the Y, and the big P, capitalized P, will gate on the Y, projects on the X. Sometimes it's hard for me to memorize, so just if you found the spectrum is not you want, just do it again. Alright, so I'll demonstrate how to do this. So go back here. So for example, I want to make a full projection. Okay, full projection means that I use a whole range of X and then gating on a whole range of X and then projecting on the Y here. How can I do that? I type O here, so the range or the line marker will push it into end here. Then I type O first, and then I type big P or big P, so I will get a projection. Okay, so this is projection. Oh, I'm sorry, I have set a background. So go back to the first one that I set. Ctrl V to set background to 0. Then I type O to push this to the end. Then I type P. You have to wait a little bit because that takes some time. So this is gating on the X4 range here. Okay, so this is 0.5, 0.5 something is 4. Conversion from original ROOTSCOPE matrices to the TH2 file, so you have 0.5. That would be fine. So you get number 6. This is one you created, and number 2 is automatic project. That should be similar. Yes, you see similar. Okay. So if you have background set, for example, you want to gate on this peak, so you set a background, click, and hit anything like big P or small p, let's see, and you have background subtraction here, and you gate on this range, and this is what coincident with this peak here. Oh, I don't know what the peak is, which peak. That's just remind myself a little bit. I think this peak I know, this peak is from the nuclei I studied. So I gate on that. Then I try small peak first. Okay. Yes. So I see my gamma rays. That's this one, this one, this one, this one. That's all I'm familiar with very easily. That's good. Okay. So this is a background subtraction. Talking about background subtraction, there are two different ways. First is what I already demonstrated using the fraction mode. That means that you set the background higher is subtraction more. You can set, this over range. Sorry, you cannot say it, or you can set very high and then you subtract more. Another way to do the subtraction is to use this add gate and subtract gate. For example, this is the real peak I want, so I gate on that. But I think this is the area is the background, so I right click and right click. And so after projection, I will project actually two histograms. So this is a real one I want, and I'll subtract the desirable one here. There's a background. So I select that. I hit Control P. Select this is the add gate range. This and the subtraction gate region range here. And I select X or Y here. Now I just try X. I don't know which one I will get. Okay. All right. So this is the thing you got. So the background will be used different way. So you have a range instead of a value. So 9 and 8. So this is the fraction mode. This is the add and subtract mode here. Okay. Alright, I think I will stop here a little bit for taking a break.